You know, we think we know our cities, right? The big roads, the official maps. But what if I told you there's a hidden circulatory system, a whole network of invisible arteries that show how a city actually moves?
And I'm not just talking about the noisy four-lane boulevards that show up on every map. I mean the quiet little shortcuts, the well-worn paths through the park, the real, pulsing lifeblood of a community. For so long, these crucial movements were a total black box for the very people designing our world.
I mean, city planners were basically working with an incomplete map, trying to design neighborhoods with a huge piece of the puzzle just missing. A study in Bali, for instance, pointed this out perfectly. It showed how this lack of knowledge led to substandard bike paths that just didn't connect with how people really wanted to get around.
So let's talk about that. Section 1. The planner's blind spot. The core problem here wasn't a lack of trying. It was about not having the right kind of data to begin with.
Just think about the old way of doing things. You'd send someone out with a clipboard to stand on a corner for a couple of hours on a Tuesday. I mean, not only is that super expensive, it gives you this tiny, static little snapshot in time. It completely misses the dynamic 24/7 rhythm of how people are actually living, working, and moving through their city.
Which brings us to Section 2, a flood of digital breadcrumbs. So what changed? Well, the answer is in this amazing trail of digital breadcrumbs that millions of us are leaving behind every single day.
Every single day, millions of us use GPS apps like Strava to track our bike rides, our runs, our walks. And Strava figured out that this created an absolutely incredible global data set. So through their Metro program, they take all this data, they make it completely anonymous, stripping away every bit of personal info to protect privacy, and then they aggregate it all.
And what this gives city planners is just wow. It's powerful. All of a sudden, they can see which trails people actually prefer. They can pinpoint dangerous intersections. They can even measure the real-world impact of a new bike lane. It's kind of like turning on the lights in a room that's been pitch black for decades.
So, Section 3, from tracks to heat maps. How do you go from all these digital breadcrumbs to something a planner can actually use? Well, this is where the magic happens. It's about turning all that raw data into real insight.
It's really a four-step journey. First, you've got the collection of all that raw user activity. Then, that data gets aggregated to start seeing the basic patterns. But the really crucial third step is enrichment, adding other layers of context. And finally, from all of that, you can generate some truly actionable insights.
The key tool for all of this is something called a Geographic Information System, or GIS. Using powerful software like QGIS, planners can process all this information and create these stunningly detailed heat maps. You can literally watch the city's hidden arteries start to glow on the screen. It's amazing.
Okay, Section 4, seeing the whole picture. Now, this all sounds incredible, but it brings us to a really important question. As cool as these heat maps are we really seeing the whole story? Or is there a catch?
And yeah, when you start to dig into the raw data, you find a pretty clear pattern. Take a look at this 2014 data from Johannesburg. It shows a staggering 80% of the trips logged on Strava were for recreation. Only 20% were for daily commutes.
So what does that tell us? It reveals a classic sampling bias. The kind of person who uses Strava isn't necessarily a perfect reflection of all cyclists in a city. That same research from Johannesburg found that the big cycling hotspots often lined up with more affluent suburbs, which points to a very specific user group.
And hey, this isn't just a Johannesburg thing. Researchers in the Netherlands, a cycling paradise, they noted the same thing. They said Strava data is fantastic for showing long-distance regional cycling trips, but those short, everyday trips like biking to the grocery store, they often get missed. And if planners can't see those trips, they can't plan for them.
All right, Section 5, correcting the map. This is the absolute key. If the raw data is biased, how in the world do you correct for that to build a map that's actually accurate?
Well, it starts with understanding something called the denominator problem or exposure. Think about it like this. To really understand safety, it's not enough to just know where crashes happen. You have to know how many people are on that route in the first place, right? 10 crashes on a street with 10,000 cyclists is a very different story than 10 crashes on a street with only 10 cyclists.
And this comparison just makes it so clear. On the left, without that exposure data, the busy, protected bike lanes actually look dangerous, just because that's where most of the cyclists are. But look at the right. When you factor in exposure, you see the true risk is on those commercial streets with no bike lanes at all. So how do you get that full picture? The solution is to blend your data. Researchers like a team in Sydney are using machine learning to combine Strava data with official city bike counts, with land use data, even census information. This lets them correct for that bias and build a truly accurate model of total cycling in the city.
And that brings us to our last section, a data-driven world. With this corrected, much more accurate data, planners in cities all across the globe are making a massive real-world impact.
In Sydney, for instance, this analysis uncovered a huge 22% jump in weekday cycling trips in 2020 compared to the year before. Now, that's not just a number on a page. That's the kind of hard evidence that city councils need to justify spending real money on new, better bike lanes.
And the applications are just so diverse. Through Strava's academic program, this data is being used for everything from studying the impact of extreme heat on cyclists in Atlanta to analyzing winter riding habits in Poland and even helping to find safer routes for people with disabilities in Detroit.
We're seeing this play out in big cities everywhere. London's using these insights to improve lighting and slow down traffic on its busiest routes. Amsterdam is expanding its already world-class bike networks. And in San Francisco, they're even creating smart traffic signals that can actually prioritize cyclists. This is data-driven planning in action, for real.
So just think about the journey we've been on. We went from a single anonymous GPS dot to a raw heat map with some hidden biases, and finally to a powerful, corrected model of an entire city's flow. This is how we build smarter, safer, more livable places for everyone.
We can finally see those invisible arteries that we talked about at the start. We can see the true, hidden pulse of our cities. And that really just leaves us with one big question. Now that we can actually see how our cities move, what kind of future are we going to choose to build with that knowledge?